I am going to do that. All right. So this is a good example to look at nested rational expressions. Nested meaning fractions within fractions, okay, and trying to simplify them. But also the properties of negative exponents, okay. So let's specifically, let's look at this and what that means. 12x to the negative second power, all right. So if we come off to the side here, just to talk about what this expression is, when you have a negative exponent, okay, we quote unquote, and this is very math terminology, EE, but you flip-flop its position. So that doesn't mean in this instance that this x squared is going to move down, okay, because again, you've got to be conscious of the fact that this entire term is a part of a difference. And it's very restrictive. Addition and subtraction are very restrictive operations. They're clingy, right? They have very specific rules. So I can't just take this, remove it from this difference, and put it in the bottom. That's not how this is going to work. I have to look at each one of these individual parts, and I can change the way that specific part of the term looks, but I can't move it. I can't factor it out. I can't do anything crazy because of this subtraction, okay? What I can do is I can say, all right, well, x to the negative second power, negative exponents either create fractions or they move within a fraction that's already there. So since this is negative, I'm going to create a fraction, and anything that is raised to the negative power has to get moved into the denominator of that. But the only part of this term that's raised to the negative second power is the x. So 12x to the negative second power is 12 over x squared. So that is going to replace this. So I'm going to have 12 over x squared. This term is going to take on a similar format, but it's going to be 3 over x. I'm not going to write x to the first, I'm just going to write x if that's okay with everybody. And then I can follow the same pattern here in the denominator. I'd have 15 over x. So I have the 15 and x to the negative first. The negative first, x to the negative first moves into this denominator here. Minus 18 over x squared. I'm going to need a lot more room here. So this expression becomes this expression. This fraction bar here, try to make that a little bit bigger, wider, longer, however you want. That's that fraction bar right there. All right? Questions on that part? Okay, so now let's talk about what do we do with fractions within fractions, right? There's two things you need to do. You need to simplify the numerator and denominator separately. That's step number one. And then put them back together in that fraction and simplify that fraction, right? So we take the numerator, and this is, I would suggest, and I've made this suggestion before, I'm going to do it again. Take that numerator off to the side, into the margin, on a separate sheet of paper, whatever you need to do, okay? I need to combine these two fractions into one fraction. Create one fraction within the fraction, right? In the top and in the bottom. So take this and create one fraction from it. But to create one fraction, we need a common denominator. Very good. And if our common denominator, the best way is to identify what the least common denominator is. The fastest way is to just multiply them. But I don't need to do that in this instance because this is a multiple of that, right? In other words, all I have to do is multiply this denominator by x and it'll be x squared, just like that. So I'm going to multiply the bottom by x, multiply the top by x. So I have 12 over x squared minus 3x over x squared, and I can write that as one, sorry, running out of room again. I can write that as one fraction There's a difference here. I don't actually get to subtract 12 and 3x because one of them has an x and one of them doesn't. Okay? But I can write it as a singular fraction. And that is going to go back up top. Right? I'm going to do the same thing with this. I'll see if I can fit this in over here. So I have 15x minus 18 over x squared. It's going to take the same sort of work to get this part done, yeah? Multiply the bottom here by x, multiply the top by x. So I have 15x minus 18 over x squared. And then that's going to come back in. So my fraction overall is 12 minus 3x over x squared on the top, and on the bottom, 15x minus 18 over x squared. Give myself some more room. So we're here. Now I have a fraction on the top, I have a fraction on the bottom. I am dividing it. When we divide fractions, we multiply by the reciprocal of that bottom one. So I'm taking this, I'm multiplying by that reciprocal. Now from here, this is a great question, because from here we have to think about our process for multiplying rational expressions. When we multiply rational expressions, the first thing we should do is, we can, but the first thing we should do is factor. Factor and simplify if we can, right? In order to cross-cancel effectively, we want to have our numerator and denominators factored, right? So on the top, can I factor anything out of the top? 3. So on the top I have 3 times 4 minus x over x squared. Over here it's x squared. And you can write x squared as x times x. I know we've done that before because that's technically the factored form of x squared. On the bottom over here I can also factor out a 3. So like we said, in order to cross-cancel effectively, we want all of the factors written out. So now we can say, oh, here's an x squared, and here's an x squared, and here's a 3, and here's a 3. And I'm allowed to cancel those 3's because they are factors. They have been removed and multiplied by something. So now when I multiply straight across, all I have on the top is this 4 minus x. And all I have on the bottom is this 5x minus 6. That's it. If you're still looking at the 4 and the 6 and thinking you can cancel out a 2, you can't. They are a part. This is a part of a difference. This is a part of this difference. You don't get to cancel that.